This is a 2012 Ford Focus SEL in metallic gray with a black interior and tan leather upholstery. Killer. It's got a fuel tank capacity of 12.4 gallons, 28 miles per gallon city, 38 highway, and a proper 6-speed automatic transmission. It has a sporty demeanor and moderately advanced technology. It looks like a regular sedan. And I thought this would be the perfect car for my very special guest and lifelong best friend, Paige. She's a self-proclaimed pun enthusiast and barely knows any calculus.
The only thing I remember is derivatives, anti-derivatives.
That's good. That's a lot of it.
We learned something about washers. I don't know.
That's volume. It has to do with anti-derivatives.
And there's this thing. It was like a 3-dimensional graph thing. I wasn't even there for that. I have 23 absences in calculus.
I'm Rachel Edens, and this is Chicks in a Car Getting Coffee.
Oh wow, great to be back. What's that song, Ignition? How does it go?
It's the remix to Ignition, hot and fresh out the kitchen. I'm
Ay,
a rolling that
ay,
body, got
ay,
every man in here
ay.
wishing, sipping on coke and rum. I'm like so wooden drunk. It's the freaking weekend, baby. I'm about to have me some fun. Okay.
That was good. That was good.
That's pretty good. So Paige, what do you think of this car?
I love it. I love the
Yeah.
finish on the leather.
It's just perfect. And the
Yes.
sunroof.
Yes, I didn't have one of those.
That's amazing. It's really great. I love the technology
Yeah.
and the aux cord capabilities.
See, I don't have an aux cord either, so this is already a blow up.
Sometimes the old cars are nice, you know?
they're good.
But sometimes you just have to buy into
just-
the new technology.
You've just gotta go for it.
You've gotta buckle your seatbelt. Come on, tiny hands. We did it. We buckled our seatbelt. But that's all right. This is the perfect car
Yes,
for our day to day.
that's true.
Yes. What is your favorite thing about
Definitely
this car?
the aux cord, which sounds pretty lame. But see, my car doesn't have one of those, so I hate commercials. Like Crazy Kevin Powell. Nobody
Crazy Kevin Powell.
The only
For the
commercial-
war, Paramount Motorsports from Salem, Greensboro, Charlotte. Get pre-approved at KevinSaysYes.com. That's KevinSaysYes.com.
The only commercial that's good with Crazy Kevin Powell is when he's sick and he's like, Crazy Kevin Powell.
So, how about the quietness of the car overall?
Yeah. I like how it doesn't, there's no like rumbly, it's just like all you can hear is like the road. You know what I mean?
Yeah.
You can't hear like the engine or anything.
Uh-huh. It's pretty nice.
Yeah.
You got the cup holders in the back seat.
Whoa.
That's amazing. And then you have the steering wheel, which is perfectly equipped for tiny hands, as you
big
can
hands.
see, and big hands. You know, it's a universal steering wheel for
Yes.
any size hands.
Yeah.
It's just so nice to look out the window and see the world.
I know, there's windows everywhere.
Yeah,
It's like you're not even in
everywhere.
the car. It's crazy.
You can see everything. It's pretty roomy up here too.
Mm-hmm. A lot of foot space, leg
Yeah.
space.
Let's face it. But don't get in the back seat because it's probably not there.
There's no complicated like.
User friendly.
Yes, that's what I was looking
Yes.
for. You can tell they were focused on their customers. Looking forward to the future of automobiles. I'm done. What does charismatic mean?
It means like a personality that everyone likes.
So would you say
Like having a good personality.
the Ford Focus is charismatic?
I would. It's a very likable car.
Yes.
Okay. Here we are. This here
Wow.
is Devine.
It's so cute.
So, now that we got our coffee and you finished yours in 0.2 seconds, since when we walked in the door, there's something I want to talk to you about.
Okay.
Okay? I want to teach you some math.
Okay.
Because I don't feel like your calculus teacher did you well enough.
No.
So I need to teach you some calculus.
I'm ready.
At the level above what you're supposed to know.
That's good.
So this is a sequence. A function that assigns a unique number, a of n, to each positive integer, n. And a series is the sums of the terms in a sequence. So sequence and series. Alright, so finite and infinite. So finite is a set number. Infinite is never ending, it goes on forever. Forever. Then we have geometric and arithmetic. So, arithmetic are the addition ones, as you can tell by the addition symbol, and geometric are the multiplication ones, as you can tell by the multiplication. Arithmetic have a common difference d between each term. And then here is an important formula, right here. It's very important. Geometric have a common ratio r between each term. And there's our very important formula, right there. Right there. And this is sequences and series. Alright, so Paige, now that I've told you what sequences and series are, do you feel like you're ready for some examples?
Yes.
Yes. So we're first going to do an arithmetic sequence example, where we're using two terms of the sequence to find the explicit formula. Remember, the explicit formula is that formula on the first sheet that we just looked at. So, we're using the terms a of 3 equals 11 and a of 12 equals 47. So, we're going to plug these values in, and we're going to deduce a of 1 and the common difference d. So, we plug in a of 3 equals 11, we get 11 equals a of 1 plus 2 minus 1d. And then we plug in a of 12 equals 47, and we get 47 equals a of 1 plus 12 minus 1d. Now, we subtract the second equation from the first equation, and we end up with 4 equals d. We can plug that difference in to our simpler formula, which is the first one, and find a of 1. When we plug that in, we get a of 1 equals 3. So our explicit formula is a of n equals 3 plus n minus 1 times 4. Next, we're looking at a geometric example. And in this example, we want to find a of 4 and an expression for the nth term using a of 1 equals 24 and a of 3 equals 6. So, we're going to plug in a of 3 equals 6 to find r, because we already know a of 1 equals 24. So 6 equals 24 times r to the 3 minus 1. So we get 1/4 equals r squared. And that goes to 1/2 equals r. So now we have a of 1 and r, and we can use our explicit formula. So a of n equals 24 times 1/2 to the n minus 1. Now we can find a of 4. A of 4 equals 24 times 1/2 to the 4 minus 1. And when that's simplified, we get a of 4 equals 3. Simple enough, right? Now on to series. We already know that most series in math are infinite. So, when we're finding the sum of a series, we're either going to use s of k to find the partial sum for just a few terms in a series, or s to infinity to find the sum to infinity. But remember, s to infinity can only be used for a geometric series. So s of k for the partial sum. S of k equals a of 1 plus a 2 plus dot 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 plus a of k minus 1 plus a of k. This can be written much nicer in sigma notation, which is s of k equals the sum from I equals 1 to I equals k. So, our sum formulas for our partial sums for arithmetic sequences are going to be s of n equals n over 2 times 2 a of 1 plus n minus 1 times d. The top formula can be used as well, but the bottom is more useful. For geometric series, we're going to use s of n equals a of 1 times 1 minus r to the n over 1 minus r, where r cannot equal 1. Now, when using s to infinity, we're going to think about limits, because the limits of series have a lot to do with whether or not a series has a sum to infinity. Now, if a series converges, then there will be a sum to infinity, and it can be found using our sigma notation in our s to infinity formula, which is a of 1 over 1 minus r. However, if the series diverges, there will not be a sum to infinity. we're going to move right into a geometric example because arithmetic examples are pretty self-explanatory and you're probably bored. So, for our geometric example, we're going to write the segment notation of and find the sum to infinity of u of n equals 3 over 5 to the n. So the first thing we're going to do is write out some of our terms. So u of 1 equals 3/5, u2 equals 3 over 25, and u5 equals 3 over 125. So, by looking at these terms, we can see that r is 1 over 5. Each term is being multiplied by 1/5 to get to the next term. Also, we know that our first term is 3/5. So, we can write this in segment notation as the sum from k equals 1 to infinity of 3 over 5 to the k. So now what we're going to do to find our sum to infinity is simply use our formula. S of infinity equals a over 1, 3/5 over 1 minus. We get s to infinity equals 3/5 times 5/4. That means the 5's cancel and we get s to infinity equals 3/4. So, using segment notation, the sum from k equals 1 to infinity of 3 over 5 to the k equals 3/4.
So Paige, do you understand sequences and series now?
I do.
That's so fantastic. So that means my work here is done. And we can go have some more fun in that fancy, fantastic car.
I love learning.
I'm so glad.
That is so funny.
I dare you to do a Chinese stoplight right now.
What is that?
Where you get out and run around the car and get back in.
No way.
I'm not. Oh, this is where you gotta do it. Chinese stoplight.
Oh my god, no, there's a car behind us.
It's okay. You, when I'm stopped.
Do I have to run all the way around?
Yeah, you just run around the car. Ready, go.
I'm so scared.
Go. High five.
Book thing. People.
What?
People are like are really bad.
The
drivers.
heck? Ah!
This calls for another pun. Wow.
Nature is just amazing, isn't it? Such a beautiful day.
So neat. Neat nature.
So neat.
neat
We
nature.
love nature.
Yeah.
You know what's really neat?
Nature.
Horses.
Oh yes.
Horses are very neat. I wonder if we can find some. Let's go look. Unfortunately, my day with Paige had to end, but we both enjoyed the math, the coffee, and the awesome car.
Hey, that's a nice car!